All right. Am I on? How exciting. Okay. Hello, everyone. Welcome. Welcome in. There are a lot of you because it's midday on Tuesday and no one's had too much fun yet. Welcome. My talk is called Is Your Code Working For You? My name is Nikki Armstrong. I am the lead programmer at Silver Brain Games. That's my Twitter. I don't post anything except pictures of my dog, but you're welcome to find me there. The main thing that we are going to learn today is if my 12-year-old laptop has enough battery to last 45 minutes. So get excited. Right. This talk was a different talk when I pitched it. But that's okay. We're going to go on a journey. What I've discovered is that it's like 30 degrees. I'm Australian and I feel disgusting, so I don't know how the rest of you are managing. And we're just going to have a bit of fun. And I hope that you are here for me. But if on your feedback form at the end, you want to put in not as described, that's probably fair, to be honest. Right, so is your code working for you? Or are you working for your code? Are you finding that it is way too hard to write code that passes code review and passes your own standards and conforms to all of the rules that you might have been told over your career of like, you have to do this, and if you write this kind of thing, it's bad, and if you use the standard library, that's probably a bad idea. Is it really just difficult to write code that you think is good code or that other people think is good code? So I hopefully am here to tell you that maybe it doesn't actually matter. While I was writing this talk, I found this tweet, which I like, which is, I believe, the biggest enemy of software engineers. Software engineers fight is the deep and common belief that one-size-fits-all solutions to problems, even hypothetical problems, always exist. And accepting that they don't leads to better code. And I really liked that tweet because so many times I'm going to put up some code and someone else is going to be like, do you know what? It's not going to work if your data looks like this. And it's not going to work if like in 3 years' time we want to change it to do this. And I'm an old woman now and I'm very tired. And I would just like to write the code that works now and not really worry about the rest of it. So let's see how we can do that. Takeaways. Understand for yourself what your code does. Stick up for yourself. Your code needs to work for you. It doesn't need to work for somebody else. It needs to work for you. Obviously, if you're in a team situation, it needs to work for the team. But hopefully you can have the confidence to convince your team that your code is good code. Understand for yourself what is important. What do you actually need to worry about right now? Is right now a time where you need to be worrying about performance? Or is right now a time where you need to be worrying about your junior being able to read the code that you just wrote? Choose who you take advice from. Make sure that you have trusted mentors, trusted peers, trusted leads, trusted seniors that you are taking advice from to make sure that your code does what you want it to do and that your code solves the problem you need it to solve and that your code pays attention to the things you need it to pay attention to right now. Do not take advice from some random on Twitter. Some random hot take on Twitter is not going to help you write good code for you. It's just going to make you angry. Delete your Twitter. Life is short. Life is too short to spend 4 hours trying to refactor a thing to make it like 1 microsecond faster. It doesn't matter. It's 2022. So when I pitched this talk, I had a bunch of examples that I wanted to go through. I wanted to go through like a bunch of different code snippets, different languages, beginner to advanced stuff, dream big. What I'm going to do is talk about for loops. It turns out you can unpack for loops. A lot of stuff you can do with a for loop. So we're just going to talk for 45 minutes about for loops. Are we excited? I'm excited. Right. Woo! I didn't think that was going to get a cheer, I'm going to be honest. What time is it? 4 minutes past 12. I'm going to try not to talk so fast. I'm also going to try not to keep you here till 4 o'clock. So for loops, questions. How do you write the best for loop? Is there an objective answer to that? What do you need to consider? What do you need to consider when you're writing your for loop? Are there any rules that anyone has memorized? Are there any rules that anyone's been taught? Are there any rules where every time you write a for loop, your fingers just kind of do it? Because somewhere in your subconscious, somewhere between your brain and your fingers that you're not really paying attention to, you know that this is the best way to write a for loop and everybody else is wrong, right? We're going to think about that. So what I'm going to do, I've got some slides with quotes on them. And all these quotes are things that people have told me or that I've believed over my career. And I'm going to unpack them. So the first one, in C#, the count function loops over the whole array to count all the elements in it every time. So never use it as your loop variable. Never ever use it as your loop variable. It's bad. It's O(n) all by itself before you consider your loop. Super bad, never do it. Somebody on my code review. A long time ago, when I didn't really know how to write C#, I'm a C++ developer, I was trying desperately to write some C# and hope nobody found out that I was bad at it. And they were like, this is the thing, don't do it. And I was like, okay, fine, I won't do it. So, is this true? Is it? Sometimes. Sometimes it's true. Do we know when it's true? I didn't know when it was true. So I Googled it because I'm a why person. I like to know why things are as they are, but I'm also a rule follower. So I will default to doing what you tell me. I also, and tell me if this is true for you, just have severe imposter syndrome. So if somebody else is telling me that my code is bad, I'm always going to be like, oh, right, yeah, sorry, my code is bad. No, you should probably fire me. Probably I should never write code again. So count is a link thing that exists on an IEnumerable. And IEnumerables don't have a cached count property. So it doesn't know what to do about that. It has to go and count everything. That part is true. An IEnumerable needs to go and count everything that is in the array on the way to telling you how many things are in there. But if you have an iCollection that is also an IEnumerable, an iCollection has a cached count property. So the count on an IEnumerable is like, well, I'm just going to check. I'm going to check if we have a cached count property. If you do, we're just going to return that. If you don't, then yes, unfortunately, I'm going to have to go through your whole array, and I'm going to count everything up, and that is going to be ON. That's fine. But in a lot of cases, it's just going to give you your cached count property off your iCollection. And a list is an iCollection. And when I'm writing C#, I'm only ever using a list. Because I don't, as previously discussed, I don't really know how to write C#. So I'm mostly using a list. So this is actually fine. Isn't that a cooler answer? Isn't it cooler now that we know what it does? Isn't it much, much cooler that we found out for ourselves in which situations this is good and in which situations this is bad? Isn't it much, much cooler than just listening to some guy 10 years ago on my code review be like, Nikki, your code is shit? There was also a blog post, link count considered occasionally harmful, that I found. There's a lot of posts like this, but I just never bothered to look them up before I was trying to put this talk together. I think that's much cooler. So what about other languages? C++, we've stood vector. Stood vector has a size function. Size accesses a cached value, so that is constant time. We're happy about that. We can use that in a loop. JavaScript, array.length, that's a property. It's not a function. It's a cached value, so it's constant time. So basically, you can do whatever you want for your loop variable. It's probably constant. It's probably fine. So we don't have to worry about what people are telling us in our code review. We can just write code that works for us. If we want to write a for loop, and we don't want to factor out our value onto another line and put that in our loop, we can just write a lovely for loop and not worry about it. Sidebar, next quote, constant time is always better. Always use the thing that takes constant time. Is that where your brains went? Because that's where my brain went until I thought about this property. Constant time doesn't mean fast, it just means constant. Your constant thing could take a whole year. It could sit there for a whole year, and at the end of the year, it could be like, hey, there are 10 things in this array. An IEnumeral looping over the array is going to take, it's going to be much, much quicker than the constant thing that sleeps for a year and then gives you the size of the things that's in the array. So constant time is not always better, but if people are going to tell you that constant time is better, maybe you need to think about that for yourself before you just listen to other people. So the thing we actually need to worry about, beyond any of this, is what is the name of that function? Because what I've discovered is that we've got a count, we've got a size, we've got a length, we've got a num unreal. Why is it called num? I don't understand. I mean, I love that for you, but I'm going to write count and it's going to not compile every time. So what we have this. This is Nikki code. I've written my own. My array, how big is it? We're going to do some work. This is an absolutely fine for loop. If you want to write a for loop that looks like that, it is absolutely fine. It is the same as this one. This one is not better. Do not let anybody tell you that this one is better. However, if you are going to do this, I'm going to come along and do this. So you should probably do this. If you want to do that, completely fine. Please make it const. But it's not better than the other one. It's just there. So write your code the way that you want to write it. All right, next quote. In JavaScript, backwards loops are faster. Is this a thing we believe? Does anybody here even write JavaScript? It's okay if you don't. I was a web dev, shamefully. This is a thing that I was told. This was an exam question. This was on my exam. This has been burned into my brain since 2007. Backwards loops are faster. Always write a backwards loop. Do we know this for ourselves? Or have we just always been told that this is true and we've believed it for 15 years? Was it true at one point, but maybe it's not true anymore? So like maybe the language has evolved. It's JavaScript, maybe not. Maybe the language has evolved. Maybe the hardware is better. Maybe the compilers are better. Like maybe it's fine now, but maybe in 2007 it was true. Where did it even come from? Like why is a backwards loop faster if it is even faster? Why is it faster? What about other languages? Like if it's true in JavaScript, why have I never been told that it's true in C#? And why have I never been told that it's true in C++? And why have I never been told that this is true in any other language? Like what's weird about JavaScript? Lots of things, but what's weird specifically about forwards loops that they're so slow? So it's not. It's not. They're not. It's not even commonly agreed upon between JavaScript developers. I tried Googling this, and what I found were forums of people arguing, which was really fun. I don't recommend you do that. But it's not commonly agreed between JavaScript developers that it's faster. It might be faster, depending on your data set and the type of your data set, depending on your thing that you are doing, it might be faster. If you've got like 1 million things in your array or more, it may be like microseconds faster. But if you've got that many things in your array, why are you using JavaScript? I mean, that would be my question. So what I want for all of you is to no longer just believe what people tell you. Go and figure it out. Write the code, profile your specific code, inspect the assembly. Maybe you want to look at your compiled C++ and see, like, is the actual output of this different? Is it different? Is it like several million more instructions? Or is it just something that you've been told is true? Write some small test cases and test those things before you go and like foray out into your main data. Just like figure these things out for yourself. Make sure that you're writing code that you understand and that works for you. So this is what I did. Let's get to the next slide. This is what I did. I wrote a forwards loop and a backwards loop. In C++, forward was faster by for 60% of the runs that I did. But like by microseconds, like if I hadn't been printing it out to that degree, I wouldn't have noticed that it was different. And this is over like millions of elements in my array. My poor laptop was overheating trying to do this for me. In JavaScript, it was like 50-50. There's no difference. Doesn't matter. Write whatever you want. Doesn't matter. So then I Googled why people thought that this might be the case. And it turns out that it's that pesky loop variable. People were saying, you know, you've got, when you do it forwards, you put the loop variable in there where your number of elements is. And then every time you go around the loop, you're accessing that thing. And even if it's not order n, it is a function call or it is a property access, right? That is an extra instruction that you're doing every single time you go around your loop. So that is going to be slower than if you do it once at the beginning and then you never access that property again. So I factored it out, made it const, and I did it again, and there was no difference. Didn't matter. Absolutely no difference. Does not matter. So do whatever you want, basically. I also looked at the assembly. I don't know if anybody can see what that says, but both sides are the same. So it doesn't matter. There's no extra instructions. It doesn't matter. So when should you use a backwards loop? Do you want to use a backwards loop? Do you want to use a forwards loop? Does it work better for your brain? The only valid reason to do it is if your brain works better if you've written your loop backwards. In that case, go nuts. Otherwise, don't let people tell you have to write your loops backwards. Write them forwards. Most people think better forwards. It's going to be okay. No one's going to die. Right, next quote. What time is it? Good question. Oh, we've got ages. Fab. Always pre-increment rather than post-increment. Same lecturer that gave the exam. I'm starting to think he didn't really know what he was talking about. But he was a lecturer that I really respected. He was a really smart guy. He'd been a programmer for a long time. He's probably dead now, but he was fab. And my whole life, I have pre-incremented my loop index because he told me to. So we've got ++i versus i++. If you're not with me, I'm going to explain. In all of the loop examples on previous slides, I was pre-incrementing because that's what my fingers do. It comes out of my fingers. It feels comfortable for me because I was told it was better, and now it's automatic. So what we've got is we've got on the left-hand side, we're pre-incrementing. And what that means is that if you care about what I is, it will update the value of I and then return it for you. So we're pre-incrementing before we do the assignment into A. So what we have is I equals 1, and then we increment I to 2, and then we assign I to A. So at the end, we've got I equals 2 and A equals 2. On the other side, we've got I equals 1, and then we do a post increment, which means we assign I to A, and then we increment I. So I equals 2, but A equals 1. That's the difference. If we're doing that in a loop, does that matter? No, it doesn't matter. What it's doing is it's doing an extra instruction on this side. Technically, this is doing an extra instruction because it's caching that value of I that you had before. You need to know what the value is. But it's probably being optimized away. It's 2022. Probably the compiler is smarter than that. Probably the compiler can figure out that you don't need it in your loop. And it's probably taken it away. Even if it wasn't, is this going to matter? Does it really matter if it's doing one extra instruction if the art teams put 1 billion draw calls into your game? Does it really matter? The answer is yes. In some cases, yes. 100% yes. But figure out for yourself if you've got one of those cases. Don't just write it because you think that it's better. Profile it, figure it out, understand which compiler you're using. Some compilers might not optimize it away. If you're like deep down in the belly of the engine code, maybe this is important. But if you're writing a user interface, maybe it's not. But can we prove it? Can we prove that it doesn't matter? I gave it a crack. Here's the code. Again, you probably can't see this, but they look pretty identical to me. So I was excited about that. They look basically the same. This is an order 1 optimization. Do you want to see what it does? So I've got pre-inc function and then a post-inc function. Do you want to see what this does when it's order 3 optimization? It does that. It's exactly the same. It's just like, do you know what? I'm not even going to give you the assembly for this. I don't care. The compiler doesn't care. So why should you care? And the answer is that you shouldn't. Do you like pre-incrementing? Do you like post-incrementing? Do whichever one you want. Next thing. An index for loop is closer to what the compiler is doing, so it's faster. Does that sound familiar? Some code bro, probably. I know this code bro. I don't know, not this specific code bro, but I have met these code bros throughout my career. Games Industry Stop Gatekeeping Women Challenge 2022. 2022, user range 4. Me. Like, it's fine. It's going to be fine. Do you want to see the assembler for this? I want to show you the assembler for this. Right, so I'm not going to pretend that both sides are the same, because they're not. Do you know what neither of them are? Neither of them look anything like an indexed loop. So your indexed loop is not closer to what the compiler is doing. Your indexed loop is just an indexed loop. So what does really matter? I did some speed tests on this. I did index loops. I averaged over 20 runs. My computer caught fire. They were 50-50 each way, index versus range, largely dependent on whether my computer was thinking about something else at the time, which one was faster. Each time, only microseconds are in it. So do you want to use an index loop? Go for your life. Don't let people tell you that a range loop is bad, though. If you want to use a range loop, use a range loop. Figure out for yourself which one you want to use. Don't let some guy on Twitter tell you that you can't. For me, in my code, I find a range loop more readable. It's going to tell me in kind of natural language what it wants to do, and that's the way that my brain works. It's going to say, for every single one of these in this array, I'm going to do some stuff. And I like the way that that reads. I find that very readable. I also can't screw up the indexing. I can't actually accidentally use a J instead of an I. I can't, like, if I've nested my loops, I use the wrong index variable in the wrong place. I can't accidentally not have a non-const count and assign it to be something else. Basically, I'm dumb and I can't mess it up if I use a range loop. But sometimes you do need the index. Like if you want to access like this one and the next one, or you want to do something else weird, sometimes you're going to need the index. And I've seen people bend over backwards to try and use a ranged loop to do a thing that they could write in 5 minutes using an index loop, because something in their brain is telling them that a ranged loop is better. And it's not. Because this isn't about me. This is about you. Can you read it? Can everybody on the team read it? Does it do what you want? Did you write it, and did it take you less than 4 hours to write? Because it shouldn't take you 4 hours to write a for loop. So there's no best answer here. There's only the best answer for you in your code in this moment. That is the best answer. That is the best for loop that you can be using. Next quote. If you're going to add a lot of elements into your vector, reserve that space first, or resize it if you want all of your default elements there at the start. What you don't want to be doing is you don't want to be just pushing back into your vector without like allocating that space first, right? Because every time you push back into your vector, if there's not enough space in it, it's going to like copy all the elements across. It's going to give you like a double-sized vector, and you might not need all of that space. It's like, obviously, not doing this is bad, right? Right? So I tested it because this is where I got to at this point of writing this talk. I got to, actually, I don't know what's true anymore. So I created a std vector. I pushed back 1,000,000 ints, and I ran some tests doing nothing, and then reserving all of the space, and then resizing it. And I ran a bunch of runs, and I took the average, and I learned how to properly like profile code in this way. So I wanted to get you good answers. You don't want me up here telling you nonsense. And what I discovered was that they were all about the same. So that's in microseconds. That's like 0.025 seconds for each of them. I don't really care that one of them took a tiny little bit longer than the rest of them. So probably didn't matter if you don't resize the first. It's probably fine. But then I was like, no, Nikki, what you've done is you've just used integers, and integers are primitive type. You probably want to do something a bit more interesting. Like usually you don't just want 1,000,000 ints. It's not a very useful thing. Like try and make this a bit of a useful example, Nikki. Maybe try. So I had a little object instead. So I've got a vector of objects which take an int because I still wanted to use my index variable. If I'm going to be writing an index loop, I want to be using that I for something. And I pushed back into my array instead. And I profiled that because I figured that if you are reserving the space, like that's the point, you're reserving enough space for all of these objects that are going to go into an array. If you're using a resize, this is what you want to be doing. So I've done a little test like this, and this is where I ended up. So what we've got here is that reserve is actually like, that's a bit faster. That might be something that you care about if you've got a large data set. Probably, I mean, I did 1,000,000, so if you've got more than that, you probably care more. I don't normally have 1,000,000 things in my game that I need to deal with, but if you do, like maybe this is better. But the resize was like, it was quite slow. And so I was like, that seems wrong. And I don't want to stand here and tell you something that's wrong, but that seems wrong. I don't know if that's wrong. And I realized what I was doing was this. And that's because I just wrote the same code, and like I showed you on the previous slides, I just uncommented the line that I wanted and ran the test again, right? That's because I was doing this. And my brain, because it's been 30 degrees, didn't realize that this was wrong. Some of you will have realized that this is wrong, and that's why it's slow. But some of you might not have, and that's the point. And this is why you need to understand for yourself what your code does and not kind of listen to other people and kind of apply the rules and kind of get them a bit wrong. Because what you should be doing is this. When you do it like this, that's how fast it is. That's much faster than the other way. Much, much faster, because you've given yourself a bunch of default objects. All of your array indices are valid, so you can go through your array and you can just do an assignment. And that's much, much faster. And so I Googled it, and I got a quote from a forum. I think this guy was angry, but I'm going to get you what he said because I thought it was quite good. Let me see if I can find it. Great question. Here, can you find it? Maybe you can't. Oh gosh, that's embarrassing. Basically, he was saying that what you need to know at like the core level is if your pushback, which is going to be doing a copy assignment or like a copy construct, is going to be slower than creating defaults and then doing an assignment. And if you're at the point where you understand that for your particular object, then absolutely go for your life. If you're not, then wait until it's a problem. Write whichever for loop makes you happy, and then wait until it's a problem. Wait until you've profiled your code. Don't prematurely optimize is what I'm saying. If you absolutely know that for your specific object that you've made, one of these types of construction is going to be faster than the other, like absolutely go for it. But don't tell other people what they should be doing for a start, because you might be wrong for their particular data. And don't beat yourself up trying to write the best kind of for loop, because what I've proven over the last half an hour is that they're all the same. It doesn't matter. But the other thing that I discovered is that I'm still doing this test wrong. This test is still wrong, because what I'm profiling is just this bit, right? But how long does this take? So I profiled it again, and what I discovered is that this time, the reserve was faster, because it takes a long time to make all those default objects. But that's still not bad. That's not slow. It's fine. It's fine. Just have fun. Just write cool code. Why are you worried about how long it's taking? All right. Erasing. Most common reason to use a backwards loop is because you want to get things out of it, right? You want to go backwards. You want to get things out of it. You want your iterators to be valid. Sounds messy, though. Like, I was trying to come up with an example to put on the code slide, and I'm just going to leave that as an exercise for the reader, because I just do this in C++, chuck everything at the end of the array that you don't want, kick it off the end. Is this slower than writing your own backwards loop? Probably not. It's somebody's job to make sure that this is fast, right? Some people that are very much smarter than me, it's their job to make sure that that works and is performant and is probably fast for your use case. So check your loops. Is your loop an algorithm? Maybe use the algorithm. Probably the fastest and safest and bug-freest way is to use the algorithm, because your code might be fast, but it also might not do what you want. You might have chucked a bug in there accidentally or done something weird with your index. And if there's an algorithm for it, use the algorithm. It's usually fine for 99% of use cases. And we like to pretend that games are the 1%, and in some cases, games are the 1%. But it's like 99% of that 1% is fine. It's higher level than you ever are going to need to care about. So stop caring about it until it's a problem. And stop letting other people tell you that your code is bad because you didn't care about some obscure thing that, like, maybe this is going to be bad on the PS4. It's probably fine. But test it for yourself. If I'm going to encourage you to do anything, like, don't just change your code because somebody told you to. Like, actually test it for yourself. And if you can prove to them that your code is fine, it's such a good feeling. All right, I'm going to move on. I'm going to move away from for loops. Are we excited? Yeah. I mean, you cheered for for loops, so I could just stay here for a bit. What is the best sorting algorithm? No, bubble sort. This was Barack Obama's whiteboard interview for Google. I don't think he passed. But that's okay, because Google rejected me as well, so I'm in good company. What is the best sorting algorithm? It's a trick question. It's std sort. Or it's algo sort. Or it's list.sort. Or it's any sorting algorithm you did not write yourself. Please don't write sorting algorithms. Why are we doing this? So pretty much all built-ins use intro sort, which is defined as the partition size is less than or equal to 16 elements. It's going to use insertion sort. If the number of partitions exceeds 2 log n, where n is the range of the input array, it's going to use heap sort. And then for everything else, it uses quick sort. Is that what you were going to write? If you were going to write your own sorting algorithm, is that what you're going to write? Because if that's what you're going to write, It's already been written for you. This is a solved problem, guys. If you weren't going to write that, it's not going to be as good. So why would you bother? So it's implemented like this on purpose to cover the 99% of cases. So you should be default assuming that you are in the 99%. Stop solving problems that you don't have before you have them. Write a std sort, just chuck it in there, and then if it's proven to be a bottleneck, you can do something else. But until it's proven to be a bottleneck, don't beat yourself up, and don't let somebody else beat you up. And, crucially, stop making people do this in interviews. I don't want to write a sorting algorithm in an interview. I had to do bubble sort with post-it notes in an interview and like show how the sorting out. I don't care. It's a solved problem. Somebody else solved it for me. What is a good interview question? All these sorts are unstable. That's a good thing to know. I don't care how fast it is. It's probably faster than anything I could write. But all these sorts are unstable. So if you need a stable sort, if you want to, and like, it took me a while to even figure out why I might want a stable sort. But if you, I guess if you want to chain your sorts, so if you want to sort on like first name, then last name, you might want to have it that when you sort the second time, guaranteed that the first time doesn't get messed up. So all your first names are in the right order, and then you do last names, and it doesn't get switched around. So that you might validly need a stable sort. That's a reasonable interview question. So how do you write a good stable sort? You don't. You can have one of these. So there's stable sort, there's enumerable to order by. There are so many options. So the thing that you need to know is not how do I write a fast sorting algorithm. It's what kind of sorting algorithm do I need for my use case. If after all of this, you can prove that you have an issue, write a custom sorting algorithm. Absolutely you can do that. But remember, the compiler is smarter than you. It is so much smarter than you. It does all sorts of fancy things. The people who wrote these do for a living. They do this. It's their job. And writing gameplay code is way more fun than writing a performance sorting algorithm. I don't want to do that. I want to write AI, and I want to fix the level streaming. I want to do those things. I don't want to write sorting algorithms. So go do that instead, and stop being worried about what you're doing, and stop being worried about what other people are doing. Just let them live their lives. So to recap, what actually matters? What have we learned? What is important? What other people have told you is true, and you've always believed. This is the most important thing to remember. No, it's not. Understanding for yourself whether a construct is important or not is important. For your data, for your use case, for your compiler, these are the important things that you need to remember. Right, real programmers. What's a real programmer? A real programmer uses the tools available to them to make sure that they are writing good code. A real programmer uses algorithms. A real programmer just writes their code and then profiles it later. A real programmer doesn't prematurely optimize. A real programmer doesn't use butterflies. A real programmer doesn't make other people feel bad for writing code that might be slightly suboptimal in like 1% of cases. A real programmer doesn't put hot takes on Twitter about how bad everybody else is at coding. A real programmer just has fun and writes code. Coding is supposed to be a creative endeavor. It's supposed to be fun. You're supposed to spend a weekend and at the end of it have a game. You're not supposed to spend a weekend trying to make your game run like 0.00001 second faster than it did on Friday night. Because that's not fun. If it is fun for you, I'm not being mean. Like, please keep doing that. But for most of the people that I know, and certainly for me, it's not fun. That's not what I want to be doing. 10 minutes? Okay. I don't think I have 10 minutes of material left, to be honest. So we're going well. What is important? Can you read it? Did it not take you 5 hours to write? Can you understand it? Will you understand it in 6 months' time? Will you remember why you wrote it in this way? Can everybody on your team understand it? There is absolutely no point in you writing something obscure as heck that runs marginally faster if your juniors can't read it. If your juniors can't read and learn from your code, there was no point in you spending that time making it whatever it is, because your juniors need to be able to read it. They need to be able to go in there confidently and edit your code and make it do something else. Don't put barriers up where there don't need to be barriers. Have you profiled it? Do you need to? Is this a piece of code that's likely to be a bottleneck? If so, profile it and then do something different if it's provably a problem. But it's probably fine. What else is important? So coding standards are important. Your coding standard might say use this particular type of loop, or it might say use this particular type of construct. And that is valid. We want all of our code to be like conformant. We want everybody to be able to read the code. We want everybody to be doing vaguely similar things. I don't want to be able to look at a piece of code and be like, oh, you know, so-and-so wrote that bit of code because it's got this thing in it. That's not what we want. So the coding standards for your company may prefer one thing over another, and that is a valid reason to write one thing over another. But are coding standards immutable? Or can they change? Can we ask why something is in a coding standard? Yes, we absolutely can. So on my team, we have quarterly coding standard meetings. And anybody on the team, right, from bottom up to top, can put in a proposal of something that they want to change in the coding standard. And they can say, hey, Nikki, this is in the coding standard, and maybe I don't agree. Or this isn't in the coding standard, and maybe it should be. And we talk about that as a team, and it's a really nice like learning and bonding exercise. And at the end of it, if there were any changes, I put them in the coding standard, I update the Clang format file, and we've changed the coding standard. There's no point in having a coding standard that's 20 years old that says you should do X over Y, because so much has changed over that 20 years. Some people on my team weren't born 20 years ago. So yeah, the coding standards are important, but they're also not unchangeable. What else is important? Code reviews are important. So somebody's going to look at your code and they're going to be like, oh, Nikki, I don't really agree with what you've written there. You've done a little index loop, haven't you, Nikki? And those are terrible. Don't do those. But you can stand up for yourself in a code review. Please stand up for yourselves in code reviews. Please don't let other people tell you that your code is bad with no reason just because like they're showing off. You can ask why something is important. If someone says do this over this, ask them why. If they can't explain themselves, don't change it. It's fine. You can push back on nitpicking. Like, let's stop nitpicking. Or something that one of the members of my team does is he prefaces his nitpicks with nitpick. So he'll say, nitpick this thing. You don't have to change it, but I need to get it out of my system. And I really like that because then he is solving a thing that is internal to him. Oh, sorry, that's terrible. And he's saying, you know, I would like you to change this because it makes me antsy that you've done it this way. But I'm aware that it's a nitpick. I'm aware that it's not probably actually a problem. I'm aware that I'm being nitpicky. So you don't have to change this, but I need to say it. And I really like that. You can disagree. What I did for like maybe the first 5 years of my career is anybody that put anything on my code review, first of all, I was scared to open them. I would not click on them because I was scared to be told that I was bad at my job. And then when I clicked on them, I would get like even the smallest comment, even the comment that was like, oh, you forgot to update this comment and now it's out of date. I would be like, oh no, like any minute now I'm gonna get fired. But like now you can disagree. Use code reviews as a learning exercise, not a gatekeeping exercise, not an absolute mess of this senior is showing off to all the juniors. Have a discussion, use it as a learning exercise, do tests together, do some profiling together. Like use it as a good thing for the team. What's important? Does your code do something cool? Are you proud of it? Did you not waste a bunch of time optimizing when you don't need to? Unless you find that fun, obviously, in which case absolutely do it. But these are the things, like when I was writing this talk, this is what I think is important. Is your code cool? Are you proud of it? Did you write it in a reasonable amount of time? That is all we care about. I've just been told I have 5 minutes left, so I'm going to stop there because that is the end of the talk. If you do have questions, please ask them. But if you're listening to the talk, maybe you don't have questions.
Hello.
Hello.
Hello. How much do you think these statements of ancient wisdom were relevant like when computers were much more primitive, and how much do you think that that's basically become insignificant considering how quickly they process and just how much memory we have these days?
100%. A lot of these things I think probably were valid at one point. And there's loads of others. I just focused on for loops. Like there's loads of other things you could probably drag up where it's like, oh, you definitely should always do this because reasons. I definitely think that they probably were true at one point. I think that they're probably still true if you're programming for like the playdate or something like that, that is, you know, limited instruction set, limited memory. And that is a fun challenge. Some people will enjoy programming in that way because it is a fun challenge. But these days, I don't think that you need to worry about those things unless they are provably a problem. So if you can prove that this piece of code is a bottleneck because you've used X over Y, then absolutely go and change it. But you shouldn't be writing the like optimal or optimized version first, partially because it's a waste of time, partially because in some cases it's not even true. So.
So in a scenario in which you want to profile or optimize some code because it's significant and run a lot or something like that, you mentioned that you're using the profiling tools. You're looking at the the compiled instructions. Do you have any tips for how to go about that? Because I have no information about how to manage profiling tools, how to look at the output of the compiler. Until now, it's been pretty alien to me. Do you have any tips?
100%. Okay, so there's this incredible website you can go to called Compiler Explorer. And I had the website for like all of the code is in my slides that I looked at. It's the godbolt.org because it was made by Matt Godbolt, who's like kind of big in the C++ community. So Compiler Explorer is amazing because you just write the code and you can pick what compiler. There's like tons of different compilers you can use. You can, in some cases, different compilers will do different things, and you can check like what's my compiler doing. So that's very cool. Unreal has Unreal Insights, which is very, very cool. And it like will break down what every like frame is doing and everything that's running there, and like it'll highlight in like big red, like this is the problem that you have. So I found a pretty significant problem in my code that way. Like real code I was working on at work, where something was being garbage collected that I didn't want it to be, and then that was a blocking thing. But I would never have found that without the profiler. I was just like, oh, this is taking a long time. I don't know. So that's super good. Usually languages will have a high resolution clock you can use. So you just do start, stop, tell me how long it took. Yeah, stuff like that. Am I coming over here now?
I think this might have to be the last one, by the
Okay.
way. I worry this might be a quite large question as well. So I'm a server engineer, which means that I don't actually write video games. I just get to watch people do so.
Fun.
So one of the things we found on our team was that we write very simple. Server code's great because it's usually optimized already. It's got the whole thing in JavaScript where it's, oh yes, it's all been done before.
Yeah, yeah.
And we work in far nicer languages like Golang, so we don't have to worry about the standard library. But the problem we end up doing is we find other ways of arguing on our code reviews instead. So we're very much in the sort of view of things like domain-driven design. And so I was going to ask, what do you do when the solution architect shows up on your code review and says, oh yes, this code's all completely fine. I know these words, but we're using microservices in this project. We need to make this more containerized. So you need to build this in a sort of hexagonal architecture. You need to move this into the application layer. How do you what's a good way of us avoiding having those occupy 90% of our code bases?
Oh my goodness.
It's a massive topic, yes.
I mean, if there is a valid architectural reason, like that person is the expert. So if there is a valid architectural reason that you need to do one thing over another, then absolutely do that. But I'm like that 3-year-old that's just why is the only question. So time's up, apparently. So I would just say like, why? Why do I need to do this? Like, don't tell me what to do, tell me why I should do it. And then I'm on board. But if you can't give me a good why, I'm not gonna. Okay, that's it. Sorry, everyone. Go have lunch.